Okay, this tutorial on Fusion, we are going to try to do 4 things because we have a short lesson, we don't have a double. We're going to try to show 4 things that you can do for your car, and we're going to then try to get into an orthographic drawing. I'm assuming at this point that you've done the tutorials or at least have some understanding of Fusion from the tower tasks. They'll give you the general understanding of the interface of Fusion 360. So we're going to go straight into something taking off from there. So you have your empty thing over here. You can start doing your drawing. We start all our Fusions with a sketch. And my dimensions here, that piece of plastic that I gave you, we can press the rectangle tool. If we press the middle and we go out, the dimensions of the rectangle tool was 200 millimeters long by 100 millimeters high. And if we press enter, that should give us a rectangle. So again, I picked the rectangle, the 2-point rectangle option over here. Alternatively, let me just check if we're still recording. Yes. Alternatively, you can do it by doing individual lines, 1, 2, 3, 4 lines. But as long as you need to close it, so you get this dark blue interior on there. And can you see dark blue on the TV? No? Okay, that's just a problem with the TV. I don't know. Yeah, I'll show you my laptop. But if you just have a quick look at my laptop, see how it's a dark blue? It's a shade? Yeah. So in your laptops, you should do it as well. As you have a closed surface, you do that. That means we can turn this into a 3D object. We're going to finish this sketch. We'll press the home button. We're going to extrude this, and we know this particular shape is 5 millimeters high, and then we press OK. And there we go. That's our piece of core flute. If we go in here in the bodies, we can even name this. We're going to right click, not right click. If we double tap the name, we can call this core. We can call it core flute, and then did it save? Core flute. Core flute and press enter. So now we have this named here. So it's going to be a bit easier as we start talking about more stuff for our car. We can also right click, we can change the appearance. Now our core flute has a particular color. So I'm going to try to find white. What will work? White ABS will work. So I'm going to get the white ABS and drag the white ABS over here. So it's going to give us a general understanding of the look of our car. Not super important for right now what we're doing with orthographic drawing, but when we start to do rendered drawings, having the color is important. So what's the big difference between this and your piece of core flute? What's missing? What does your piece of core flute have that this does not have? Holes, correct, yes. So we can press the sketch function, and if we sketch this wall over here, we can go and we can start making the holes. Now you can measure the holes, but I'm just going to approximate the holes for it. I'm going to assume that the thin pieces of plastic are going to be like 0.5 millimeter or 5 mil, maybe 1 millimeter thick is how thick the plastic will be. So I can go in here with my line. Each one of these steps is 1 millimeter for me. And I can just make if I make a square that's 3 by 3, that's my square. And I can even ensure that I am 1 millimeter away by pressing that, By pressing this button over here with my dimension tool, I can ensure that I'm 1 millimeter off from the edges. So let me just explain that again because I skipped through that one fast. Over here we have this square. I made this square. This square is a 3 by 3 millimeter square. How do we prove it? In the sketch we can use a dimension tool. And the dimension tool is saying this is a square here, but I want to give this an actual dimension. I want to officially say this is the distance I want. So if I click it and I drag my arrow out, I can see here I have my dimension. Now it's actually not exactly 3, it's slightly off 3. So if I press 3, enter, now it says this line over here is exactly 3 millimeters. Same with this line over here, exactly 3 millimeters. So you click and you drag the arrow out. You can also do the distance between 2 objects. So the distance between this line and this line should be 1. We want it to be 1. If we press 1, enter, and the distance between this line and this line, we want this to also be 1. Sure, crate driven, yeah. So now, and the last one is this one. Cool, 1. In this particular case, it's not super important because if you picked 5 millimeters high, and then the 3 millimeter hole, you're going to be approximately fine. But later when you start doing fine detail, it might matter. So we should know from this point, we're going to get this, and in 3D, we're just going to make that hole, right? By extruding it inwards. But there's a lot of holes in your core flute, and we would have to do this a lot of times, and that takes a lot of time. So instead, we're going to use the rectangular pattern tool. If we press the rectangular pattern, the objects we're going to copy is we want to copy just these lines. Right. And the direction we want to copy them, if we drag this arrow backwards, we start to have the line, we start to see these squares popping up. Let's see if I can put that on a better part of the screen for you. Right. And how many do I want? I can keep increasing the quantity. Now, as I increase the quantity, see how they're overlapping? That's because currently I have this as extent. So that means for between this distance and this distance, that's the maximum distance that I want the drawings to be apart. So fit as many of them as you can in there. Instead of extent, I want us to change it to spacing. So that's going to be the space between each of these copies. So I think it's going to be 5 millimeters. Is it 5? No. Minus 5. No, not minus 5, minus 4. So now that I do minus 4, see how these individual squares, they're the ones that we're going to cut out of our core flutes. And I can, come over here please. All I've got to do now is zoom out and keep upping this number until the squares go through a whole piece of core flute. Right, that's good enough. And then we press OK, and so now we're going to have all these squares here. And it doesn't matter in your drawing if the squares go over this particular end piece. That's not super important because just like when we cut the core flute, sometimes you had the pieces of your core flute sticking out. Doesn't matter for our drawing. In fact, it makes it look more real, if anything. We can now finish this sketch, and we'll look in 3D again. So we now got to extrude these. If we press the extrusion tool, yes, we can select every one of these and then just drag this arrow backwards and would make the hole. Yes, you can do that. It works, but it's slow and you might miss one and it gets annoying. The other option is, right, if we select the outside, right, well then that's going to do like the opposite, right? It's just going to cut the outside and we're going to just be left with the tubes. But over here under the operation we have cut. If we change this to intersect, that's going to say between this piece this extrusion and the original piece, just pick the parts that are overlapping. So that should just be the outside of our core flute. And just as a note, extrusion is typically blue, cutting is usually red, intersection is yellow. So you could mentally know what shape you're doing. And if I press OK here, oh, look at that. Now that's like an actual piece of core flute there. If you are doing your drawing by hand, yes, you will have to draw all the individual squares in your drawing to be as good as a Fusion 360 drawing. Okay, we've done that. What's next on our list? Revolve. Okay, so we need some wheels. So what we're going to do here is I'm going to hide this body for now. We'll deal with this body later. So under the body, if you press that I button, you just hide it. Do we remember what was the dimensions of the wheel?
5 diameter.
Yep.
Diameter, and it's like 2 centimeters width.
2, okay, 5 and 2 centimeters. So we're going to go to sketch. And so what I'm going to do here, to do the wheel, the simple, one of the ways you can do it is you make a circle and we then extrude that into a 3D shape. But we'll do something that will teach you a bit more and will give you a bit more flexibility with how you're going to design this, and it's going to be a lot better, especially when you want to make the pulleys as well. So instead of making it the circle and then extruding into 3D, we are going to make the face and then we're going to revolve that around the axle. And we're going to make a revolve tool. So how do we do that? So we're going to go to line. So you said it is 50 millimeters in diameter? Okay, so if we go over here, we can do 50 divided by 2 because we're only doing like half of the wheel as we revolve it. And it's 2 centimeters, 20 millimeters over here. And then we go down like this. And we're gonna revolve it from this middle piece. But this is just going to be a boring cylinder. We may as well show off some extra features that you can do with the revolve tool. Now, your wheels aren't exactly perpendicular 90 degrees at the corner. They're slightly tapered. So we can do that in this tool. We can go to fillet. We can click this corner over here, and we can press this corner over here, and we can change this radius to 1 millimeter to give the wheel some. That's what the corner of the wheel would look like. And we can even make a little rectangle like this, and we can use our rectangular pattern tool that we used before. So what I'm doing here is your wheels have little grooves in them, right? Probably 5. Not extend. So I'm copying these grooves. We want it to be like this. And then if we press Finish Sketch, so this is going to be our 2D shape that we're going to turn into 3D. One other thing that we do have to consider is the wheel is not a solid cylinder, right? If you look at it from the back, you can see it's almost hollow from one side. And we can do that in here as well. Before I finish this sketch, we're going to right click and edit the sketch again. So the inside of the wheel is actually hollow, so we can press this. I don't know what the actual inside of the wheel looks like, but I assume it looks something like this. So that will be our wheel, and then if we finish, so we have this particular shape over here. Now we're going to do the revolve tool. If we go create, revolve, let's see what revolve says. Revolve, because you haven't done this with your towel before, the revolve tool. Revolve a sketch, profile, or planar face around a selected axis. So you pick a shape and the axis, and it's going to go in a circle around that. Revolve, the shape we want is this shape over here. Where we want to rotate it about is that shape over there. And that's now our wheel. Now that looks like a good version of our wheel. Do you want me to do that again?
Yeah.
Okay. Cancel. So this particular shape over here, that's the 2D version of the shape of the wheel. We press the revolve tool. This is the profile, and this is the axis. And I'll show you, and if we do this, bam, it's in 3D. Now, we'll do the back, but yeah, I'll show you the back. Inside of your wheel. So, revolve doesn't also have to be 360. You can do it in a smaller one, but this might be a better visual understanding of what's happening. So that's the shape, and we're rotating that shape in 360. And that will then be our wheel. Right, so that's a particular wheel of the car. Now it's not aligned up, but we can fix that later. Before we do that, let's just give it a name. Wheel. What else did we have to do? We had to make the axle for the wheel to connect to. So we can do that. We can go sketch over here. Now we know we want our axle to go. Let's hide this wheel. We want our axle to go into these particular holes over here, and we can do that. Create. By default, it's not going to attach inside here. So if we want to have a circle be relevant to this, we have to go project and include, project this particular shape here and then we can make our circle. How do we make our circle? How do we make our circle? We make our circle 3 tangent circle. We want this line, and this line. Okay. So that's a circle fitting inside that square exactly. And now we want to make this particular circle. We're going to extrude this circle. Now typically when you extrude, right, you've seen extrusions before, you can do it that way, but we want this circle to go both in and out. I don't know the exact length of your metal, so I'm just going to approximate it for my drawing here. You can change yours later. But let's say we want it to go 10 millimeters out this way, but we also want it to go the other way as well. We want it to extrude in both directions. So over here, instead of us picking one side, we can press 2 sides, and then we can drag the other side as well. So this one should be 110, I assume. The whole axle is 120, so that's good because we picked 100, 10, and 10. So yeah. Okay, so that should be axle. I'm not going to do the white shaft, but you can do that yourself later if you want. So we have this, and we can just call this body axle. All right. Now we have to attach this wheel to this axle. Again, this is a lovely thing about Fusion. We can kind of do this automatically. So I would like all eyes on here. This is an important one for your drawing. If we press the you have 2 ways you can move it. You can either press this move and copy. If we press this shape, before we move an object, we have to say where we want to move it from. Now in the lateral directions, X, Y, and Z, it doesn't actually matter where you move it from, but what it does matter is the rotation. Like if you were rotating it from the very top, it's going to be different than if you rotate it from the bottom. So we pick where we want to move this wheel from, okay, and then we can just drag it by moving these arrows. We can move the wheel anywhere we want, right? So you can visually move it until you think it's fine. There's also an option in Fusion for it to attach it exactly to another object, and that's the Align tool. The Align tool moves an object's component, body, sketch, work, geometry by aligning geometries of the 2 selected objects. So if we press Align and we want to align this circle. Now see how there's this little square reticle type of thing that shows up? It's saying, well, this flat surface, but the center of the circle, it's what it's trying to do. We can click that and see how it's highlighted in blue. And we want to attach this to this thing over here. And then it should move the wheel to there. All right. Is this the exact location for your car? It's not bad. Technically, they're not inside each other yet, so it's like you haven't pushed the wheel in. But this is where you can do, and you can also flip it around if you want it to be the other way. Sometimes that will matter depending on how you align it. But now that you have this object here, now if you want to say, oh, I actually want it to be 5 millimeters in, well then you can press the object, and over here, see this Z distance, you can make this minus 5 millimeters. And so now it's actually inwards 5, and so that should be closer there. Okay? And that's how you got your wheel of your car. We can also use the copy tool. So we have this wheel over here. We want the same wheel to be on the other side. So what we can do over here is if we can go right here, we can press this. So if we have this body selected, we press over here the move/copy. We're going to use the copy part now. How you do this, before you press any movement, you can only copy it if you have not moved it yet. So I've selected the object, I haven't moved it, and this little box is allowed to be clicked, create a copy. Watch what happens. As soon as I start to move it, the box grays out. So the move/copy, I don't know why Fusion does it this way, but if you want to copy it, you click the object you want to copy, and then you press create copy. I think it's because you start moving the copy is why it does this. So for this copy, we want to move this wheel over to here, right? And what we can do is instead of moving it manually, once we physically separate the object, we can do our Align tool again. Align, We want to align this with this. And this particular case, it's the wrong way around, so we can flip it. And now we have this wheel, these pair of wheels over here. So now you're going to get to the stage where we're going to have to do stuff like make the motor. The motor actually isn't that difficult, because once you know the shape of your motor, which you can make the shape of our motor. I'm just trying to select this face. So the shape of your motor is actually, and we'll just approximate. The shape of your motor is approximately like something like this, and it has this is approximately the shape of your motor. And that's approximately the shape of your motor. But remember, when you're extruding an object and it's touching another object, it by default will want to join that particular object. So you'd have to make a new body. And this is also a reason why I liked making that core flute white. So if I was extruding something and I see it's also white, I can know, oh, that wants to attach to the core flute. If you're attaching like a spoiler, that's fine, because your spoiler is probably also going to be made of core flute. You're not that concerned if it's the same object. But this being this motor, no, we don't want that. I just guessed it. I think it's about 20 millimeters. The circle part is 20 millimeters, I think. But I just guessed the size of this motor. You'll go in the workshop, you'll measure your motor. So we have the motor here. Now I want to make the belt, is the last part. You don't need me to show you how to make the pulley, because you've already done, the pulley is just the wheel. You do that same thing. It's like you do a capital M shape, and you revolve that, and you're going to get the pulley. But the belt going around the pulley, that's the more interesting one in my opinion. So what we're going to do here is we're going to make a sketch, and we'll make the sketch at this plane over here. Now, the pulley is basically a rubber band, and it goes around a big circle and a small circle. So we can do that here. We're going to make a circle. We want the circle to be in the middle, this circle to be over here. Do you remember, do we have the diameters of the big and small pulley by any chance? The small one is like 10 or 15? 1.12, yep. That's the small one. And what's the big one? 37 diameter?
Yeah, diameter.
Nice. So this is the diameter of the two pulleys. So what we need to do now is we need to make a line that connects what is the way to do this? Just give me a second, I'm thinking about this one. And then that makes sense. Okay, so yes, we can do this. So how do we do this? It's going to be a bit tricky. Now, for the sake of the demonstration, we're going to hide all the other pieces of bodies. So what I had here is I had two circles. I want to find a tangent that's connecting those two circles. That's what our belt's basically going to be. It's going to be the tangent of those two circles. Fusion is a bit, it's not as, it doesn't have a way to directly make a line a tangent of two circles. So what we do is we press the line button. The first thing we want to do is I want to fix this particular shape here, and I want to fix this shape. So now they shouldn't move. Enter. I want to then press the line, and I want to make a line between this circle and this circle. Now this is clearly not a tangent, right? It touches the circumference, but it is not a tangent. So what we can do here is if we go to this these constraints up here, if we press tangent, if we press this and this, now that line is a tangent. And we can do the same here. We can press this and this, and now that line is a tangent. So now that's clearly, that looks like what the belt would go around those two things. Okay, we can finish that sketch. And as we finish sketches, it should bring back, oh no, it's not going to bring back. All right, so now we have to make the ring that's going to go around that. How I have made this, or how I'm thinking of making it, we need to make a little circle that is the diameter of the O-ring, and then we're going to rotate that around the whole object. Before we can do that, we have to make a plane to do our sketch on, which we don't actually have yet. So we're going to make a plane along a path. If we press this path over here, so we're going to make a plane in that on there, press OK. Now we can sketch on here. And do we know the diameter of that little rubber band? It's probably like 1 millimeter, right? We'll just assume it's 1 millimeter. 1. Right, it's 1 millimeter. Press finish sketch. Now for this one, we have to make sure we keep this original sketch. So now we have this little rubber band and we have this sketch. What we're going to do is we're going to use the last tool before we start finding our drawing in 3D, orthographic, is we're going to use the sweep tool. So sweep gets an object and it makes it follow the line. So we press sweep. The object we want, the profile we want to do that to is this little circle. And the path we want is this. And then we're going to go even more. Why isn't it doing the circle? I don't know why it's not doing the circle. I guess we can do this the manual way. Oh, it's single path. Okay, why didn't this work? What is wrong with this sketch? Right click, edit sketch. Maybe I need to do, maybe I need to make this arc a bit better. All right. So I think one of the issues here is, see how this is green because I made it fixed? I think that means it's not going to be used in the sketch, while this line is black, so that can be used. So the way that I just thought is go to create and make an arc, and now an arc is part of a circle. If we press that center point and we start it from where the tangent started, and if we actually bring our mouse close to it, we should get that little blue square. And then if we drag this around here, so now this whole thing should have the black circle. Now we'll go to that, now we'll do the sweep tool again. Sweep. We will select this shape. And if we press this path, nice. Okay, so this does look nice. Now, if you have this particular option over here, selected as parallel, it's not going to work because that's parallel as if it's like it's a 2D shape, like my hand. It's going to keep doing this, which we don't, in our particular case, we don't want to do this. Sometimes you do want to do this, like, let's say you do a house and there's a fence that goes along the side of the house. You want your fence posts to always be parallel as you're copying them down the path. But if you're doing, in this case, we want the circle to go with the curvature. So we're going to make it perpendicular. We have this circle, wonderful, and now that's now our rubber, our band. You can finish off your drawing by, adding the pulleys. The other advantage you have is we can click this, click the axle, click the other wheel. We can copy these whole parts. Make a copy, and we can make our front wheels as well. Right. Front wheels, done. Let's assume that they're lined up. They're probably not, but you can fine tune to make sure they go inside the holes. So cool, we have our car done now. Let's go and save this. Save this in... what class? Y? Yeah. Cool. We have our car saved. Now, so the time you spend in this is mostly in the CAD thing, and you can change the colors of everything you want and put more details. Like even in the wheels, you can also do the spokes. Since you know how to do the revolving pattern, you did that with your tower in the last task to make the rods go in a circle. Once you have this made, this is how fast the orthographic drawing is. Right? You can press design, drawing from design. We want this whole body, A3 paper, sure. Press OK. Then over here, we press the view we want. So see how here's the car. Now before I actually press the button down, that's actually quite small, right? We can have our car larger. So let's actually go, I don't know if 2 to 1. Yeah, 2 to 1 will work. So there's our car. I can just click the button and press OK. And boom, car's done. Orthographic drawing done. Right. Orthographic drawing is done. And the more detail you put in, the better. Sometimes you might not want the hidden detail to come out, so you can actually edit it. And you can say, oh, I don't actually want the hidden detail to show up. So you can, how do you do that? This one over here. Only visible edges. You can remove hidden detail if you want. You can also make this orthographic with the render of the colors if you so wish. For our ones, this one is fine, or the hidden detail one, they're both fine. So you do this.
Does it automatically do the third angle projection?
Well, we'll have a look. So we have this. If you press over here, the projected view, we'll click this button. So I have my glue, I press this and bam, on top. Bam, to the side. Ooh, give me that diagonal angle. This, give me that. You don't have to do all of these, right? But why not? If you have them, it's so easy, right? And then once you're done, you press enter, I think, enter. Oh, look, they're all done. I don't like this one. Go away, delete. Right? Oh, I don't actually like the locations of this. So remember, one of the key things of the orthographic drawing is they have to be aligned. So like, I want it to actually be 1 millimeter to the left. So hold on, let me just drag. It drags all the drawings with it to be aligned. Right? So if I do this, if I bring this over here, it drags all these drawings, so they're always going to be aligned because that's the rule of orthographic. This 3D one isn't, but it's nice to have that 3D drawing. So cool. Wow, that's easy. Actually, this part is so much faster. It's all about the CAD stuff that's difficult. Now you can also do the dimensions. If you press this dimension button over here, what's the diameter of this wheel? Bam, I'll give you that. 5 millimeters. You just click it and it comes out. What is the piece of core flute? How much do I need? Well, I can click it and I can drag it out. I need 200. And these will be, when you finish your drawing, these will be there. There's some stuff it might not do, but maybe the distance between, you want to know where the motor is to the rear axle maybe. Can you do that? No, I think because it's hidden. Maybe you can do dimension from where the motor is to here. No, that's not popping up. Maybe that one, we'll have to do it in another view. Maybe the top view is the better one to do this. So you can find out how far away your motor has to be. 959. You can do all these. You can do all these things. You can also, in your text, type in like the date. Whatever the date is, right? You can add that there, and you can write in the text and fill up this over here. And then when you're ready, you can, you save it in both Fusion, but then you also export it as the PDF, and you can just put that PDF into your Word doc.
So we only make the Like the original?
Yeah, not the original, just one of
Does
them.
it matter which one?
No.
Like, do we get that in marks for?
No, it doesn't matter. I get that it's going to be one of your iterative designs will be this. But for a good orthographic drawing, you need the 3 views. They have to be aligned. You need the title block filled up with information in it. Not all of this, because some of this, like the department, doesn't matter. But you definitely need the name of it. Now notice here, 2024 drag car 9Y. That's the name that we made of the file. So that's kind of good. The date and the scale isn't here, so you'll have to put in the scale somewhere. But you do need to put dimensions. How many dimensions? Not every single dimensions, but show me that you know how to use a dimension tool. Same as if you're doing it by paper, show me that you know how to do dimensions. Important things if you're doing it by hand. Your dimensions do need to have this line and this arrow. And this arrow is exactly, I think it's 3 mil by 1 mil size. The arrow has to be precise. This over here is the symbol for diameter. And then you go to export it. That will be it for this particular tutorial. Ooh, where are we going?